everybody, my name is Sophie and welcome to our HSC Standard Maths September lecture for 2023. I'm super excited to have you guys here with me. Today you are here with ATAR Notes. As I said, my name is Sophie. We have heaps to get through today. It's a 2-hour lecture, so we're going to go ahead and get started. The first thing I wanted to quickly chat to you guys about was ATAR Notes. Who are we? What do we offer? And why is it a good idea that you're here right now? So ATAR Notes is a nationwide company that I work for that specializes in creating and providing HSC students with majority free resources, but also paid resources that help you succeed as a student. If you are interested in checking anything out, head to atarnotes.com/register. When it comes to our free resources, they are in abundance. We have hundreds, if not thousands, of downloadable study notes. We have our free lecture series that run 4 times a year in January, April, July and September, of which you are attending your last round of lectures. We have discussions and online Q&A sessions. We have videos to encourage engaging online revision. We have our newsletters, our ATAR calculator, if that's something you like to use, and our articles that explore different study strategies and tips. There's also heaps more on our brand new website, so go ahead and head to atarnotes.com/register if you are in those last kind of 2 weeks of school or 2 weeks of studying or whatever it is, last couple of weeks, and you're prioritizing getting that study as good as you can. Head to atarnotes.com for your free resources. So at the time that this lecture is being broadcast, there are 19 days until the standard maths exam. So the standard maths exam is taking place on Monday, the 16th of October, 2023 from 9:20 a.m. to 12 p.m. That is a date that will hopefully not live in infamy in your head and you will promptly forget once you've sat the exam. But for now, it is 19 days away. So how will this lecture work if we're looking at an exam that is about 2.5 weeks away? This is a pre-recorded lecture with a live chat. So I'm currently not able to see your messages. I will not be able to respond to you over video, and I am just recording a 2-hour lecture for you. However, you can ask questions by using the chat, and I myself am currently in the chat. So this same version of me, just at the time of the lecture, is in the chat with you. This is pre-recorded. So I'll be active in the chat to answer any questions that you have. You can ask questions about what's on the slides. You can ask questions about the practice questions. You can ask questions about the HSC, or how to study, or how to find practice papers, or how to not procrastinate. You can ask all of those questions. Usually at the end of the lecture, I will do a wrap up where I kind of run through the questions I get asked most frequently, because they're usually the same ones every lecture. So I can kind of give you those answers over the video, but I can also answer them in the chat. I would also recommend downloading the slides. You can do this at any time, and the video will be available after the lecture. Both are great, as I tend to speak quite fast, and there are lots of questions in here that we might not do as in depth and you want to come back to. So what is our plan for today? The first thing we're going to do is revise the structure of the exam, and we're going to talk about timing the sections properly and revising our reference sheet. Mine is very beat up because I've been using it for years now, but revising our reference sheet. We're also going to talk about preparation techniques leading up to the exam, and also things you can think about doing on the actual day of the exam. Then we'll get straight into exam questions. So there's going to be about 5 to 7 exam questions for each topic in the syllabus, and we're going to be doing network, statistical analysis, algebra, measurement, and financial maths. Those are the 5 topics that will make up your exam on the day. Your job is to work alongside me to answer these questions in your own time. Ask any further questions you may have in the chat, and I will answer them as quickly as I can. So here's kind of a breakdown of our lecture. We're going to approach the exam first off, talk about that. Content block 1 will be networks and stats. Content block 2 will be algebra, measurement, and financial. And then we'll do a wrap up with last minute questions and tips. And you should be able to see that there is a kind of tracker down the bottom of our slides so that you can follow along and see what section we're in. I'd also note that whilst there are 2 content blocks, if you've attended ATAR Notes lectures in the past, you may be used to our breaks. We don't have breaks anymore. It's just 2 hours instead of 2.5 with breaks. So if you need a break, feel free to jump up and grab a drink of water, pop to the bathroom, grab something to eat. I will not be taking a break, but you can always come back and rewatch the section that you missed. So a little bit about me. My name is Sophie. I graduated in 2020 from Bethany College in Hurstville. I had an ATAR of 95.6. I studied English Advanced, Standard Mathematics, SOR 1, Modern History, History Extension, and Society and Culture when I was in Year 12. I also did English Extension until like the middle of Year 12, and I did Ancient History in Year 11. Standard Maths was my best subject. It was my highest band 6. I am now studying a Bachelor of Arts Laws at the University of New South Wales, of which I am currently in my final term of my 3rd year. I have a beautiful German Shepherd named Luna. You may hear her during the lecture. She likes to bark sometimes. She's been sprayed with the hose today to get a little bit of a bath. There she goes. I believe my dad's doing some gardening and she's not allowed to be with him while he's doing it, so she sounds a bit upset. I would say that in high school I was a bit of a teacher's pet in a hopefully cooler way, but I feel like I should take that out. I don't think that's actually what I was. But what I'm trying to say is that if you are here attending this lecture and you are putting in the work, it's not something to be ashamed of or embarrassed of. Good work and hard work is something to be proud of. And if you feel like, you've copped a bit of teasing, whatever it is, for putting in hard work and caring about your HSC, and everyone's told you, oh, it doesn't matter, don't worry about it. I'm also one of those people who would tell you it doesn't matter, but it's not something to be ashamed of, and you should be proud that you are putting in the work. I guarantee I procrastinate more than you. I say this every lecture and it's remained true, although I think I am getting a little bit better after about 15 years, but I can give you all of my procrastination tips at the end of the lecture. One of my non-academic tips for the HSC is to plan something amazing for afterwards. I went on an incredible camping trip with 7 of my best friends. It was some of the best days of my life. I loved it so much, and if you can plan something, I would very much recommend it. So throughout today's lecture, you are able to ask me questions at any time via the chat. There will also be quiz questions where you can put the answer you think it is, A, B, C, or D, in the chat. So I'll be checking this all the time, not just periodically, but all the time as I'm sitting there answering your questions. So ask any questions that you may have along the way. Just keep in mind, I'm not going to be able to answer them over the lecture. You'll have to read the chat. So we're going to start by breaking down the exam itself. So how does this exam work? The Standard 2 exam, even though it's a 2-unit subject, it's not a 3-hour exam like other 2-unit subjects like modern or business or advanced maths or biology. It's not a 3-hour exam. It's 2 hours and 30 minutes with 10 minutes of reading time. Now that's 2 hours and 40 minutes, which is basically like 3 hours. But look, you're missing an extra half an hour of working time. And you're still doing 100 marks. So it doesn't work out exactly the same mark split as other exams. You must write using a black pen. You can use a calculator approved by NESA. If you've been using a calculator in Year 12, likely it's one that's approved. This is my Casio FX82AU plus 2 that I've had since 2015 when I was in Year 7. So it's going on 9 years old. Still works, even though you can't see the numbers anymore, and it's just me knowing by muscle memory where they are. But make sure you have a working calculator. An important point here is that you will not be allowed to go into the exam before they watch you go shift, I'm trying to remember what it is, shift, setup, I can't remember the actual code, but basically they tell you what to put in, and you have to as you walk into the room, you have to hit a button and they watch you reset your calculator. So if you think you can pre-program something in there, you can't. They're going to watch you reset it. A reference sheet is provided at the back of your paper. This is the one that I used in Year 12, not in my actual exam, but when I was studying. And as it says, for questions in section 2, i.e. 85 marks, you need to show working. So we have 2 sections. Section 1, which is 15 marks. Questions 1 to 15 are multiple choice. It says allow about 25 minutes. Usually it won't take that long, but you are able to allow about 25 minutes. And section 2 is 85 marks. That is your short answer questions or long answer, whatever you want to call them. And that is the section they recommend allowing 2 hours and 5 minutes for. So as I said, it works out about 1.5 minutes per mark. All of those things are important. Okay, the reference sheet. This is what the sheet will look like when you sit the exam. It's the same one that I have here roughly, although mine is the slightly older one, which they used to give you a bit of a different situation on the measurement side. They just go length, area, surface area, and volume and list them all out. Now they're actually broken down into length, area, surface area, and volume. Apart from that, it is all the same, except they used to not give you the sine, cos, tan ratios. They do now, and it just used to be a different order over here. But essentially, this is mostly the same. You're lucky that they've kind of expanded it. This is what it will look like in the exam. It's very important to keep in mind that, see how, it'll say volume or area. It's not telling you what you're actually calculating. So you want to be able to understand what we are calculating. The first one here is arc length. This is when you have, and I'll draw it out for you, a circle, and they're asking you to find the length of this part to this part. Now say that this internal angle is 120. This theta would be 120 over 360 times 2 pi r, and that would be that length there that you found. The next thing that they've given you is the area of a sector of a circle. So same thing there, the angle goes in, but you're finding the area of that piece of the pizza, not just the edge of the crust. The trapezium is the next one, h over 2 or height over 2, a plus b, and the trapezoidal rule. Fairly similar. It is basically the same formula. You're adding the same things, but you're finding the area of two different shapes. They're literally exactly the same, but they're two different things still. That is the surface area of a cylinder. The 2 pi r squared represents the two flat circles. Let's pretend that my water bottle didn't have this top bit. It would be this circle, and the 2 pi r h is the bit that wraps around. And then the second one is a sphere. Area equals 4 pi r squared. This top one is the volume of a cone or pyramid, 1 over 3 area times height, and 4 over 3 pi r cubed is the volume of a sphere. So we have our right angle trigonometry, which is our sine opposite over hypotenuse, cos adjacent over hypotenuse, and tan opposite over adjacent. And then we have our area of a non-right angled triangle. To find the area of a right angled triangle, you do half base height, but to do the area of a non-right angled triangle, you do half AB sine C. The sine rule is shown there, and that is how to find a side. If you want to find an angle, remember sine A has to go on top instead, sine B, sine C. So whatever you're finding goes on top. And then we have cosine rule to find a side, and the cosine rule to find an angle. Up here, under the financial math section, we have the compound interest formula. Future value equals present value, brackets 1 plus r, close brackets to the power of n. This is not the simple interest formula, so we want to remember that the simple interest formula is I equals PRN. Jumping down, we have how to find outliers, we have our z-score formula, and then we have our normal distribution graph, where we aren't given our little percentages, we're just given our 3 big ones. So you want to remember that this is 34, this is 13.5, and this is 2.35 and 0.15. So that is your reference sheet. This is essentially going to be your Bible in the exam. As soon as you can start practicing papers, just having this next to you, the better. I would recommend doing that as soon as you can if you're not already doing it. So let's talk about exam techniques. So here are some crucial exam techniques or preparation that I would recommend. Firstly, make sure you complete at least 4 HSC general or standard maths papers. There are going to be differences in syllabus. So if you do a paper from before 2019, the questions are going to be different. So make sure that you check kind of what you're answering, because they've added things like networks, and they've also gotten rid of things. Please feel free to exceed that number. I recommend that you do, and do them multiple times. If you get a 60% on the first go round, try it again until you get that 80 or that 90 or whatever it is that you're looking for. I probably did dozens of practice papers, to be honest with you. rather than doing other ways of revising, because I found that worked best for me. Secondly, replicate the exam experience by making sure that you're doing these exams under timed conditions. It's super important that you're not just sitting there doing a practice paper with all of your notes and coming back to it 5 times in a day and checking your answers with your friends. Make sure that you sit down, even if you can't do the 2.5 hours, just do an hour of the exam. But do it without any other notes, just your reference sheet, your calculator, and your pen, and no other distractions. It's super important because the only way you'll be able to aptly prepare for the real exam is by essentially replicating it multiple times over. Thirdly, revise any concepts thoroughly that you continue to find difficult, i.e., you keep getting these questions wrong. This might be things like the type of question, so page-long worded questions, or one part of the syllabus like finding a float time, remembering your formulas, etc. One exercise that I like to do is just printing out the formula sheet and labeling everything and adding things that I like to remember in my exam. So one thing I like to remember was the formula for finding the score, not the Z score, where you... apologies, guys. Where you rearrange the Z-score formula to find the score. So instead of doing Z equals score minus average over standard deviation, you're finding the score and you're using the Z-score, the average, and the standard deviation to find it. So I like to write all over my formula sheet and annotate it as an exercise. But if you continue to get one thing wrong, you have to practice that part over and over again. It's not any use to you to ignore the problems and pretend that you'll just kind of figure them out by the time the exam comes. So here are some exam techniques I would recommend during the exam. Even if you have no idea what the question is asking, absolutely no idea, just write something down. If you write nothing, you're 100% going to get no mark. If you write something, you may potentially get half a mark, even if it's just the formula or some working that you think might be correct. Make sure you know how to clear your calculator and know what a calculator in the wrong mode looks like. So when you're sitting an exam, there should be, if you're on a Casio like I am, a little D and a little M up the top. And that's how you know you're in the correct mode. If you hit mode 2, now I'm in stats mode and I have this little table here that if I write numbers into and hit enter, things happen. So you have to know that you need to be in comp mode, which is mode or setup 1, and you need to make sure you understand how to switch between modes. Make sure you use the mark allocation of every question to guide your answers. So you need to know that if it has 3 marks, you are doing at least 3 steps. It can't just be a 1-step answer if it's a 3-mark question. Make sure you write all over your page. I wasn't really a highlighter person, but it's very helpful for a lot of people to use a highlighter to mark key points. I really underlined things that I wanted to remember and just annotate, make notes for yourself. If you want to come back to a question, fold the paper, put an asterisk there so you can review it at the end of the exam. Also, take a big deep breath, drink a little bit of water, but not too much because you don't want to have to go to the bathroom during the exam. Don't drink a coffee the morning of the exam. Make sure you eat breakfast. Have a good night's sleep. Don't talk to anyone before the exam. I prefer to be by myself because everyone freaks you out talking about all the things that they think they're going to fail. Okay, to reset calculator from any other mode, what you want to do is hit Shift 9 3, which is all, and then yes, which is the equal sign, and then AC, and you'll have reset. And this is what they make you do when you walk into the exam. Okay, so Year 11 content. This is the last thing we're going to quickly chat about before we get into our actual Year 12 content. Don't forget that about 15 to 20% of the content that you've covered in Year 11, which was prelim, will be tested in your HSC exam. So these are the 4 units you did in Year 11. You did algebra, which involved formulae and equations and linear relationships, measurement, which was applications of measurement and working with time, financial mathematics, which was money matters, and statistical analysis, which was data analysis and relative frequency and probability. I would say that working with time, applications of measurement, linear relationships, and relative frequency and probability are probably the ones that I find get tested the most in Year 12 because they have the most linkage to the Year 12 content areas. But all of these content pieces can be tested, and do note that networks wasn't something that you did in Year 11, only Year 12. Okay, so let's jump into content block 1. We're going to be looking at networks to start us off. So there are 2 parts of the network syllabus. We have network concepts, which involves the shortest path and minimum spanning trees, and we have critical path analysis, which involves the maximum flow minimum cut theorem. So we're going to be moving through both of these sections. The first thing I wanted to do is quickly remind you guys of some key terminology and definitions when it comes to networks. A network is simply a set of objects or tasks that are connected to create a sequence, and we'll be going through all of these things in the next slides. So vertices are the blue dots that have been circled. They are the towns or the people or the water reservoirs or the computers or whatever it is that's being connected in a network. The edge is the green line, which is the actual line or piece that connects 2 different things in a network. Loops are when one edge loops back into the same vertex or vertice. We can see that happening here and here. A walk is when you simply traverse any part of a network. So it doesn't have to have any requirements other than starting at one edge and moving to another. A path can look like this, but it's very important that a path does not revisit the same vertice twice. So this could not be a path as it revisits the same vertice. The degree of a vertex is the amount of edges that enter that vertex. So the degree of this is 1 as there is one edge, and the degree of this vertex is 5 as there are 1, 2, 3, 4, 5 edges linking into the vertice. A directed network is a network that has arrows between each edge showing that one edge moves into another. So this might be, researchers in a university and how many pages of research they send each other. So A might send C 12 pages while C sends B 20 pages and 32 pages to D. Weighted edges are what we've just spoken about, but without needing to be directed. So we can see that these might be the distances between different towns, 1 kilometer, 2 kilometers, 3 kilometers, and they're showing you the distance via that weighting. And do note that this stuff doesn't have to be to scale. We can see that the 1 edge is longer than the 4 edge. It doesn't actually mean anything. So here's a practice question. Observing the network below, write down the following information. So we'll start going through each of these. How many vertices are there? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vertices. How many edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 edges. What is the degree of each vertex? This would be 1, 4, 4, 4, 3, 1, 5, 1, 5, and 2. Identify a possible walk. A possible walk, I'll give you a different color to show you, could be something as simple as this. And a possible path could be something as simple as this. Notice that we didn't revisit any vertice. So we've got all of that listed out there. We've got a walk and a path. We can see that our walk revisits this vertice, whereas our path does not. And we've got 10 and 15. Okay, the next aspect of networks is what we call the shortest path. So the key to finding the shortest path in a network, which is what we can simply call the quickest route from one place to another, is what we call a minimum spanning tree. So we have trees, spanning trees, and then minimum spanning trees. A minimum spanning tree looks like any other tree, but the important rule is that you do not create any network, so you're not linking anything back to each other. So just like branches in a real tree, there's no closed circuit. This is a minimum spanning tree here. We can see how it's the shortest edges, so the 1, 3, and 4, not the 5, 9, and 10 that constitute the minimum spanning tree. It also resembles branches because there are no closed connections. So, for example, consider the following network. What is the shortest path from A to B? So if we have a look at our diagram, we can see that we have A over here and we have B over here. So option 1 is going to be AGHB, which is 4 plus 6 plus 2, which gives us a distance of 12. This is also not a directed network, so you can essentially go any way you like, but we're just trying to get from A to B. The next path we have is AEFB, and this is 6 plus 5 plus 1, which also gives us an option of 12. And our final option is ACDB, which is 4 plus 6 plus 1, which gives us a path of 11, meaning it is our shortest path. So if you are asked to answer what is the shortest path from A to B, you would write ACDB. This is another example of a network diagram with a few other bits and pieces to it. Specifically, we have the out degree and the in degree. So the out degree of C is 2 because there are 2 edges going out, and the in degree is 1 as there is 1 edge coming in. So why do we use network diagrams? They can be very useful when we're planning a sequence of events, tasks, or activities. There's generally a final objective that we're working towards. This is one of the parts of the exam that is likely to get quite realistic and longer. So these questions are the ones that you would be kind of imagining would be those 6 or 7 markers at the end of the exam. So here's another question that we just ran through with the shortest path. Again, just reiterating that when we're finding it, we're looking for the edges that add up to be the least. So even though we might start with, the same edge here, we need to test all of our edges before determining that this one would be the shortest. So as I just spoke about, we have trees, which is just a part of a network or a network that contains no cycle. The minimum spanning tree is when we've actually gotten the entire tree or the entire network connected via the minimum spanning tree, not just a tree which might be part of the network. An important tip here is that if there are 10 vertices, 10 vertices in a diagram or a network, we minus 1, there should be 9 edges in our minimum spanning tree. So here's your example of how we jump from what a tree to a minimum spanning tree looks like. This would be a tree and a minimum spanning tree as we've connected all of our edges and it's our minimum length. We aren't closing it off with cycles or circuits. We can see that this is not a tree diagram as this graph has a loop here and it also has multiple edges here. And this one is not a tree diagram as it has been connected here and also here potentially. So if we were to get rid of one of these 2 edges and connect A, then we would have a minimum spanning tree. So here's a quick question in finding a spanning tree on this network. So if I was to be finding the spanning tree on this network, I would start by highlighting or using Kruskal's algorithm personally, the shortest edges. So I would highlight 1, 2, I would then highlight 3. I'm not going to highlight this 3 because that would create a circuit. There are no other 3, so I would now highlight the 4s. I'm highlighting this 4. I'm not highlighting this 4 as it would create a circuit. There are no other edges that need to be connected, so that would technically be my minimum spanning tree, something like that. Again, this is a weighted graph and this is the minimum spanning tree of that weighted graph. So we're going to jump through some questions. This is now moving to critical path analysis. That was all your network concept stuff. This is a critical path analysis question. The network diagram represents a system of roads connecting a shopping center to an on-ramp of a freeway. Traffic moves via several routes. For example, there are 2 routes from the shopping center to P and 1 route from T to U. The number on the edge of each road indicates the number of vehicles that can travel on it per hour, which means that on this road, 70 vehicles can travel on it. This road, 115 can travel on it. At present, the capacity of the network from the shopping center to the on-ramp is not maximized. Which additional roads would increase the network capacity to its maximum? So the first thing we need to figure out is what is the maximum capacity of this network? It looks like the maximum capacity, if anything is changing U to the on-ramp, so nothing is changing U to the on-ramp. So we know that this capacity here, maximum, must be 63 plus 92, which is equal to 155 cars. So we want to make sure that 155 cars, not just 115, are able to make it to the on-ramp. So if we subtract 115 from 155, it means that there are 40 car spots or amounts of cars that we are not prioritizing adding. So we need to be able to add a capacity of 40. A road from P to U with a capacity of 20. Here, that's only going to add 20 vehicles. A road from Q to T with a capacity of 20. Again, that's only going to add 20 vehicles. A road from R to T with a capacity of 20. So R to T. And a road from T to U with a capacity of 40 vehicles. T to U. That sounds like it is potentially the correct answer. Let's have a look. A road from Q to U with a capacity of 20 vehicles. Q to U. And a road from S to U with a capacity of 20 vehicles. Now, why is that more correct? We've just done this calculation here. We'll run through. We know it can't be D. We know it can't be C, because if we're adding a road from just T to U with a capacity of 40, we're not dealing with the fact that we've only added 20 behind here. So we still aren't reaching our capacity, which means the answer has to be D. We've also vetted A. As a road from Q to U with a capacity of 20, if we draw that on, 20, and S to U with a further 20, we're bypassing this problem of only being able to fit 115 on this road. So our answer would be D. Here's our next exam question. A small scale network diagram represents the completion of an assessment task for a Year 8 student. The minimum completion time for the project is 15 days. What is the float time of activity B? So we need to do a scan to find the answer here. So we do our forward scan by adding the biggest number every time we move forward. So we always start with 0, and as we move forward, we can see here that we either have 5, and this is a dummy edge, or actually no, it should have a number on it. I'm not sure why it doesn't. Just pretend that this edge is 4. So we need to have our edge on it. So we would see that 5 plus 4 over 2 plus 3 is going to be our bigger number. We add our 6. We don't add 5 and 6 because that 5 and 1 because that would only be 6. We want to deal with our biggest number. And then we do our backward scan. So once we've done that, we can see that our critical path is here, but we always take the smallest going backwards. So we found that there is a gap here because when we jump from 9 minus 3, we get 6, not 2. So because there is a gap of 4, our float time is going to be 4 days. So our answer would be C. Oh, sorry guys, went back. That is meant to be covering C, not D. Okay, George and Tessie are constructing a cubby house. The project involves completing activities A to H. Times are in hours. Which two activities immediately precede activity G? And by completing the diagram, calculate the minimum time required to complete the renovation. So we can pretty simply answer the first part of the question by going to activity G, which is, oh, we don't want to fill that in yet. Activity G is this line here, and we can see that activity C and activity D feed into this line. So answer would be C and D. Now, by completing the diagram, we want to find the minimum time required to complete the renovation. So I will do this one with you guys now. We're always going to start at 0. Our first number is 3. We then have to add 2. So our number up here in this box would be 5. 3 plus 9 is going to be 12. But I want to double check. Does 5 plus 5 get any higher? No. So we're going to stick with 12. We then have, and we should have a box down here as well. 12 plus 11 is going to be 23. Oh, sorry, we actually don't need that box. 23 goes in there. We have 12 plus 6, which is going to be equal to 18. And then we can either do 18 plus 4, which is 22, or 12 plus 11, which is 23. We then count back. So we always start at 23. We count back. So this would be 12. 23 minus 4 would be 19. 19 minus 6, we've already done that one. 12 minus 5 is going to be 7. 12 minus 9, 3, 0. So we can see that this actually all matches up with our working. So when we're answering, we've already set activities C and D, and we already calculated that the minimum time to complete is going to be 23 hours. So we now have C and D. What are the activities involved in the critical path, and prove that the float time of B is 2 hours? To find the critical path, we simply go along the questions, the vertices that have the same number in the two boxes. So we can see that it's going to be down and across to here. So this activity is a float time, this activity has a float time, and G would also have a float time. So we've done that critical path. We now want to prove that what activities are involved, A, D, H, and we want to prove that the float time of B is 2 hours. We can see that the difference between our earliest starting time and our latest starting time are 7 and 5. So therefore, our difference is 2 hours, 5 minus 3, or just 5 minus 7, 7 minus 5 as well. Okay. Here's our final exam question for networks. A New South Wales government program requires activities A to E to be completed. The activity chart shows the immediate prerequisites and duration for each activity. So we have A, B, C, D, E, F, we have our prereqs and our duration in hours. A, by drawing a network diagram, determine the minimum time for the project to be completed. And B, determine the float time of the non-critical activity. So when we're drawing this out, we want to start by adding in all of our vertices first. So we always start with a start vertice. We draw our activity on, and then we add another vertice. So the activity is actually taking place in the line. The vertices don't represent A. They represent the start of A and the end of A, and the start of B and C, and the end of B and C, and the start of D. This is the end of D and the start of E, the end of E and the start of F, the end of F, which is the finish. So don't think of this dot as B, C, and D. Think of it as the checkpoint between the tasks. So once we've drawn all of these on, we can see that B and C were both prerequisites to D. D was the prerequisite to E, E was the prerequisite to F. We've then done our forward scan, which is the first number in the box, and our backward scan, which means that the non-critical activity, because we only have one activity that can't be on the critical path, is going to be C, as B takes longer than C. So we can see our earliest starting time was 2, our latest finishing time was 8. 8 minus 5, which is our number here, gives us a float time or an LST of 3, which means that our float time is 3 minus 2, and we get 1. But we can also just find this difference between what the number here, which was 7, and the difference between 7 and 8. So that is networks. We're now going to move on to statistics. So the first thing I want to run you guys through are a couple of things that you may have forgotten. Super basic stuff from year 11 when we're talking about scatter plots. So when we have scatter plots, we can have a positive linear pattern or a negative linear pattern. Remember that a positive is progressing upwards from the bottom left-hand corner to the top right-hand corner, and a negative linear is progressing downwards from the top left-hand to the bottom right-hand. So this is our correlation versus no correlation. So this graph here has no correlation. There is no way to effectively link all of these points together in a way that resembles anything that is linear in nature. This, however, can be correlated together, but it's a non-linear pattern. This would be something more akin to a parabola. We can also describe the strength of correlation as strong, moderate, or weak. So this is a strong correlation, as all of the points are very close to where our line of best fit is drawn. This is a moderate correlation, as it looks more like a rectangle when you draw around it. And a weak correlation is very loosely going in one direction. If we had even just one more point up here, you may argue that it's actually correlated this way. So what is a correlation coefficient? To actually express what we just talked about in numbers and not words, we use something called the correlation coefficient. So to quantify the strength of a linear association, we look at Pearson's correlation coefficient, and this is denoted by the pronumeral R. It can have a value between -1 and 1, and those values can be a perfect negative or a perfect positive, which is -1 and 1. We use the following table as a guide. So we have strong, moderate, weak, and no correlation. So if you do everything in your calculator and you get 0.7, it is a moderate positive correlation. If you get -0.25, you're dealing with a negative no correlation. So here's a key point. You are only expected to actually determine this using your calculator. It's a very advanced formula. Students are not expected to know how to calculate it by hand. So you are just expected to be able to do it when you go into mode, stats 2. And once you put all your information in, you hit AC, shift 1, and you'll see that there is 5 and you get this little R here. I don't know if you can see that, but you'll be able to find it using the R in your calculator. So remember, if it's a positive correlation, which is 0 to +1, it means that both variables are increasing or decreasing at the same time. So as the temperature increases, more ice cream gets bought. If there is 0, that means there's no correlation. Being, does the, let's see, the degree I get at university affect how much money my brother makes? No. Negative correlation, which is -1 to 0, means that as one variable increase, the other variable decreases. So it's going to look like this. And that could be something like the less, I'm trying to think of a good example. As my score in the exam goes up, as my number of marks achieved in the exam goes up, the number of time left in the exam will go down. Bit of a shoddy example, but I think you get the point. So how do we calculate this? This is in our calculator. So you want to hit mode 2 for statistics, and then you want to hit 2, which is A plus BX. Once you enter that, you'll get something that looks like this in your calculator. And it will probably be like highlighted in 1 square, which means you're currently in the X square. And you want to enter your data, say it's like 31, 32, 33, 1, 2, 3, whatever it is. You hit AC, shift, and then you hit 1, 5, and you hit this number here. And you're going to get a number like 0.7, which is a moderate positive or a strong positive, or you're going to get -0.5, which is a moderate negative. So it's very, very, very important that you remember how to do this in your calculator, because it is not something they are going to give you instructions for in the exam. So what is the line of best fit? After drawing a scatter plot using the value of ordered pairs, we may be able to draw a line of best fit. So if the points have a linear correlation, like we just spoke about, you can generally approximate a straight line graph. And we do this through something called linear regression. So it's going to model the same formula we've always dealt with, which is y equals mx plus c. So here's our example question. We usually use these points to guesstimate or estimate a line of best fit. So we've got all these points here. The first thing we're going to do is plot them onto our graph. This is what they look like. Then we can see that as the points do not exactly line up, we can draw a line of best fit. So here's a couple things you need to make sure you do when you draw a line of best fit. Number 1, make sure that your line of best fit passes through as many points as possible. If the line does not pass through a point, it must have an even amount of points on each side. And I'll show you this in the next slide. This makes sure that it evenly crosses the data and is the best fit line. So in our example, it's not going to pass through many points, but there are approximately 4 points on each side. So we can see that it passes through maybe this point, but we can see that there are 1, 2, 3, 4 points on the top of the line, and 1, 2, 3, 4 points on the bottom of the line. So always use a ruler and make sure that wherever it is that it's going, it's getting an even spread of points above and below the line. Okay, normal distribution. In normal distribution, the distribution of data is symmetrical about the mean, either side of the mean. The mean and the median are approximately equal. Remember that our median is our middle or our medium score. The bell-shaped curve is what will represent your normal distribution. This is on your sheet and it is also here. So what are the properties of our normal distribution, also known as informed by the empirical rule? This graph is a representation of it. We can see that there are three central rules. Between a z-score of -1 and 1 lies 68% of the data. Between -2 and 2 is 95% of the data. And between -3 and 3 is 99.7%, which means that either side is only an extra 0.3%, which we can see divided into 0.15 on either side. When you sit the exam, make sure that you write these percentages on your formula sheet. So get in the habit wherever you have a formula sheet, you write these down so that you practice and remember them as well as possible, because they aren't going to give you those breakdowns and you don't want to have to just always keep working them out. So empirical rule aims to help you remember these percentages. It's the 68, 95, 99.7 rule. You can always remember the percentages just on one side. So 34, 13.5, 2.35, and 0.15. It's flipped. It's the same on each side. So the z-score or the standardized score is used as a tool of comparison. It's the number of standard deviations that your score is from the mean. So to calculate a z-score, we have this formula. Z-score equals x minus mu, which is the mean, over sigma, which is S or standard deviation. So a z-score of 0 will indicate a score that is equal to the mean. A z-score of 1 is 1 standard deviation above the mean. So in a test, that's good. It means you got above the average. A z-score of -1 is 1 standard deviation below the mean. So that's not as good. You're actually below the average. So remember, the larger the z-score, the further it is from the mean of the data, which is the center. And this applies to both negative and positive numbers. So -4 is further away from the center than -3. -4 is also further away from the center than +3. So one last thing, this is your year 11 content when it comes to classifying data. I just wanted to remind you guys that all data falls into 4 categories. We have 2 parent categories. Data can be categorical, meaning it has a characteristic or is divided into categories, and data can be numerical, meaning it's numbers that we're able to count. Categorical data then has 2 subcategories. Categorical nominal means that there is no order of the categories. So something like eye color or hair color or the color of a car or brands of toothpaste. Categorical ordinal are categories that have an intrinsic order like A, B, C, D, E, F on a grade ranking. Numerical discrete means that the number takes an exact value, like the number of children in a family or the number of flowers in a bouquet. Numerical continuous data means that it can take any value within a range. So there might be 157.336 mils of water in my water bottle. Okay, we're now going to jump into some exam questions. The number of hours worked during a week by casual staff in the hospitality industry is normally distributed with a mean of 18 hours and a standard deviation of 2.5 hours. What is the percentage of casual staff working fewer than 23 hours a week? So here is our solution. We know that there is a mean of 18 and a standard deviation of 2.5. So one z-score is going to be 20.5 and 2 z-score is going to be 23 hours. We find our z-score by adding 1 standard deviation to the mean every time we move up, which means that if there are 23 hours at z-score 2, we want to find the percentage of people working less than a z-score of +2. So we know that this side on this side of the mean is already 50%. And then we know that this is 34% and this is 13.5%. And once we add all of that together, we get 97.5. Here's our next exam question. The weight of packets of Felicity's frozen fish fillets is found to be normally distributed with a mean of 512 grams and a standard deviation of 6 grams. Ben has a packet of Felicity's frozen fish fillets with a standardized weight of a Z-score 1.75. What is the actual weight of the packet? And our second question, a wholesaler sells boxes of 40 packets of Felicity's frozen fish fillets. Given that each packet is labeled as containing 500 grams, how many packets in each box would you expect to be under the labeled weight? Support your answer with appropriate calculations. So here is our solution. For our first question, we are already provided with our Z-score, and we want to find the actual weight of the packet if the Z-score is 1.75. So we're actually reversing our formula to make the score the subject of the formula. So we do some algebraic substitution here, and we times each side by 6, and then we have minus 512, so we're going to add 512 to 10.5. So our actual score, if we have a Z-score of 1.75, is going to be 522.5 grams. Our second question was to find that if each packet is labeled as containing 500 grams, how many would we expect to be under that weight? So if there is a standard deviation of 6 grams, it means that a -1 Z-score is 506 and a -2 Z-score is 500. So how much is below 500? We can see that only 2.35% of all packets lies between -2 and 3, and 0.15 lies between -3 and the rest of that side, which means that only 2.5% is going to be that section. So we're going to times that by 40 packets, meaning only one packet will ever fall below our 500 gram minimum. Our next question, in a computer game, a player scored 180, 183, 184, 186, and 192 in the first 5 rounds. After playing a 6th round, the player's average score increased by 1. What was the player's score in the 6th round? Okay, so we have our 4 multiple choice answers, 185, 186, 191, and 193. So to work this out, we want to find our initial average. And you can do this by putting the following into a calculator. I'll let you guys do this one with me. So quickly put that into your calculator. Okay, so once we've found that initial average of 185, we want to find our new average, which is going to be 186. Now, if we want to find the 6th round, we're going to add all of these together and do 925 plus x, which is our new imaginary score, over 6, because there's now 6 scores, to find an average of 186. And once we work that out, we should find that our new average is 191. My biggest advice for probability is to always draw a tree diagram every time you get a question like this. Annie is a nurse who is on call to work on Saturday and Sunday at the local hospital. If the hospital is busy, she will be called to come into work. Based on previous weekends, Annie has a 30% chance of being called into work on Saturday and a 20% chance of being called into work on Sunday. The probability tree diagram below shows the possible outcome for Annie over the weekend. So question A, what is the probability that Annie will be called into work on both days? And what is the probability that she will be called in only one day of the weekend? So we have our probability tree here. We can see that Saturday we have a 30% chance of being called in and 70 of not being called. And on Sunday we have a 20% chance of being called in and an 80% chance of not being called in. Now, always draw out your tree diagrams when you answer these questions. So the chance of getting called in on both days is going to be 30% times 20%. So we're only going to get a chance of 6%. And only one day, so we work out 2 different probabilities. 30 times 80 is 0.24, and then 70 times 20, 0.14. And if we add those 2 probabilities together, there's a 38% chance that she'll be called in on just one day. On a recent assessment task, the results were normally distributed. Jane achieved a score of 68% with a Z score of 0.5, and Justin achieved a score of 82% with a Z score of 2.25. What was the mean percent score? So we know that 68% is half a standard deviation above the mean, and 82% is 2.25 standard deviations above the mean, which means that if we take 82 and minus 68, 14% is 1.75 standard deviations. And if we then divide 14 by 1.75, it means that 8 is 1 standard deviation. So if we know that 8 is the standard deviation, we can use our Z score, our score, and our standard deviation to find the mean. And once we put that into our formula and work it out, we should find that our mean is 64. And if we go back to our question, we can see mean 64 would be D. The box and whisker plots show the results of a history test and a geography test. In history, 112 students completed the test. The number of students who scored above 30 marks was the same for the history test and the geography test. How many students completed the geography test? So if we jump into our box and whisker plots, we can see that we always want to label Q1, Q2, and Q3 on our box plots. So we can see here that if there are 112 students who completed the test in history, we need to be able to work out how many completed geography based on that information. So if above 30 was only 25% of the students, we have 28 students. 28 students received 50% in geography, meaning that 28 times 2, there were 56% of students in geography. The number of students who scored above 30 was the same for the history test and the geography test, meaning that this number here, 25% of the history cohort, is equal to 50% of the geo cohort. Once we put all of that in, 25% of the history cohort was 56, which is equal to 50% of the geo cohort, which is 56. Okay, we're now going to move into our second content block. We are about an hour into our lecture, so we're going to be jumping into algebra. The first thing we're going to look at is exponential functions. An exponential function is a non-linear curve whose equation has an x or some variable as the power. So an example would be 2 to the power of x. The general rule for this function is y equals a to the power of x. We always use exponential functions to solve growth or decay problems, like the spread of COVID or the change in currency or something like that. A quadratic function is a non-linear curve whose equation has an x as an x squared. So it's always x to the power of 2, not a to the power of x. The general rule of this is going to be ax squared plus c, and a and c are always numbers. So an example of this would be this graph, y equals x minus 3 to the power of 2 minus 2, and we can see that a is going to be minus 3, and c is going to be minus 2. So when we're talking about distinguishing quadratics from other linear relationships, or non-linear relationships rather, we learn to recognize the shape as a parabola. So a parabola has two things, a turning point and an axis of symmetry. This will allow you to always recognize a quadratic equation. Here's a quick tip. A parabola that is a smiley face has a positive gradient. A parabola with a sad face has a negative gradient. So this here is ax squared plus bx plus c, and this here is negative ax squared plus bx plus c. We can see that a positive smiles and a negative frowns. A cubic function, so we've done exponential, quadratic, and now we're on cubic. A cubic function is a non-linear curve whose equation has an x as an x cubed. So cubic, we're talking about to the power of 3. The general rule for this function is ax cubed plus 3, and it will look like this kind of curvy line. Here are some of our questions, jumping into a type of relationship question first. A gardener has created a rectangular garden bed with 24 meters of fencing using a wall as one side of the bed. The plan for the garden is shown where W meters is the width. Which equation gives the area A of the garden bed? So to work through our solution, we know that this is the width. We don't know what the side lengths are, but we know that the total fencing is going to be 24 meters. So we can start by taking 24 meters, which is our perimeter, and minus 2W, which is our width. So therefore, the area of the garden has to be the width, which remember area is width times breadth. We now know that our breadth is equal to 24 minus 2W, meaning that using our rule of expansion by timesing this by W and this by W becoming squared, it would be 24W minus 2W squared. The time it takes to clean the exterior glass of Sydney Tower varies inversely with the number of cleaners who are working. Last week, it took 8 hours for 4 cleaners to clean the glass. A. Calculate the value of the constant of variation, which is K, and use it to write the equation for the time required to clean the glass. And B. Calculate the minimum number of cleaners required to clean the glass of Sydney Tower in less than 5 hours. So last time, it took 8 hours and 4 cleaners. And we want to calculate the value of the constant K. So we're going to use our inverse variation formula, which is y equals K over C or X equals K over Y. This one we're talking about time and cleaners. So 8 hours over equals K, which is our constant, over 4. Which means that 4 times 8, because we're going to solve this algebraically, our constant is 32, which means that time will always equal 32 over cleaners. So to calculate the number of cleaners required to clean the glass of Sydney Tower in less than 5 hours, we take that formula and we substitute in the fact that we want to clean it in less than 5 hours. We can now switch our formula by timesing this side by C and dividing this side by 5 to find that 32 over 5 is 6.4 cleaners, meaning because we can't have a fourth of a person, we need 7 cleaners overall. Oh, we already answered that one. This question. Which graph best represents the equation y equals x squared minus 2? So we have a couple of different things to look at in this one. The first thing we're looking at is that it is a parabola because we have x squared minus 2. Now there is no negative in front of the x, so it cannot be our negative parabolas. Finally, we have our turning point listed as minus 2. This turning point is 2, meaning it's wrong, making A our correct answer. The graph displays the cost in dollars C charged by 2 companies for the hire of a minibus for X hours. Both companies charge $360 for the hire of a minibus for 3 hours. Firstly, what is the hourly rate charged by company A? And secondly, company B charges an initial booking fee of $75. Write a formula in the form of C equals MX plus B for the cost of hiring from company B for X hours. Okay, so we're looking at the hourly rate charged by company A. We can see that from hour 1 to hour 3, we've increased from 75 to 360. So 360 minus 75 is equal to 285. Oh, sorry, that was company B, ignore me. Company A, we can see that we've gone to 360 in 3 hours. So 360 divided by 3 is going to be equal to $120. Secondly, we want to calculate a formula that will show the cost of hiring a minibus from company B for X hours. Now, there is always a booking fee of $75, which is going to be our y-intercept. And then we want to enter our gradient, which we can see that if we do the difference between 360 and 75, which is 285, and we divide that by 3, we're going up by $95 an hour. So it's going to be, the cost is 95 times the number of hours plus the booking fee of $75. A minibus is hired for 5 hours from company B. Calculate how much cheaper this is than hiring from company A. So we know that company A is just $120 per hour. So 5 times 120 is going to be $600. And we use our formula to find our cost for company B. So 95 times 5, which was 5 hours, plus our original booking fee of 75 is going to be $550. So once we've done that, we can determine that company B is actually $50 cheaper than company A. Here's our last exam question. The graph shows the life expectancy of people born between 1900 and 2000. According to the graph, what is the life expectancy of a person born in 1932? So if we go onto our graph, we see that there are intervals of 2. So if we go up from 1932 to our line and we draw across here, we should be able to see that our life expectancy is 68 years. Our second question, with reference to the value of the gradient, explain the meaning of the gradient in this context. So the value of the gradient is actually positive. It is progressing upwards. So we can say that by using 2 points on the graph, and I'll show you how to do that now, we have this point here, which has 80 and 1980, and this point here, which has 70 and 1940. So our rise is 10 years and our run is 40 years. So 10 over 40 is equal to 0.25. We can test this in another portion of our gradient here, as we can test it on another part of the line as well if you'd like. We can test it running from here, so 70 and 1940, 60 and 1900. So the rise is 60 to 70, which is 10. The run is 1900 to 1930. So, 1940. Yep. So still 40 years, still equal to 0.25. So because our gradient is 0.25, we can explain that it represents that the life expectancy will increase by 0.25 years, which is 3 months, for every year later that a person is born. Here is our last exam question. I lied. This is also from year 11, formulating equations. Solve the equation 2x over 5 plus 1 equals 3x plus 1 over 2, leaving your answer as a fraction. So our solution. The first thing we want to do is to try and remove our fractions, even though we're going to leave our overall answer as 1. So to do this, we want to start timesing things by our denominator. So we're going to times this by 2, which actually just leaves it, we're going to times that by 2, but because there's already a 2 here, it just errors out. We're going to times this by 2, and we're going to times this by 2. And once we've done that, we should get 4x over 5 plus 2 equals 3x plus 1. Now we want to get rid of our other denominator, which was 5. So we're going to times the denominator by 5, which just removes it. Then we times everything else by 5. We should now have 4x plus 10 equals 15x plus 5. Because I want to get x on its own, I'm going to remove the whole number from this side and subtract it from the other whole number. So we're going to subtract 10 from 5. And once we've done that, we should have 4x equals 15x minus 5, because 10 minus 15 is going to be, 5 minus 10 is going to be minus 5. And now I want to subtract 15x from the back end so that I can get x on its own on the front end. So I'm going to subtract 15x from each side of my equation. And that will leave me with minus 11x equals minus 5. And we're going to do it over minus 11 on each side. And once we've done that, we should get the answer x equals 5 over 11. Okay, moving on to our second last topic, measurement. So we're going to run through a couple things first to do with the sine rule and the cosine rule. The sine rule is one way in which we can find missing sides and angles in triangles which are not right angled. So to find a missing side using the sine rule, critically you must have two angles and one side. If you want to find a missing angle, you need two sides and one angle, and they have to be corresponding to one another. So the sine rule is A over sine A equals B over sine B equals C over sine C. At any given time, you're only ever going to be using two parts. So you might just be doing A equals B, or B equals C, or C equals A. It's all arbitrary. The numbers and the letters don't actually mean anything. They're not intrinsically assigned to one side. You label a triangle how you want, as long as you follow the rules on the right-hand side of this slide. To work out which angles or sides you use, you label your triangle as follows. So side A, we use little letters to represent our sides, is always going to be opposite angle A. Side B is always going to be opposite angle B. And side C is always going to be opposite angle C. Now, unlike our right angle trigonometry, there is no need to label a certain side a certain letter because it's the biggest or the longest or the largest. They're just three different letters. So if the sine rule cannot be used, you might be able to use the cosine rule instead. This is the cosine rule to find a missing side. C squared equals A squared plus B squared minus 2AB cos C. So when we use the sine rule, that involves two sides and two angles, one of which you need to find. And the cosine rule will involve all three sides and one angle. If you want to be able to find anything in a right angle or non-right angle triangle, generally speaking, you're going to use one or the other. If you want to find an angle using the cosine rule, you need to have all three sides. So here is our kind of master diagram of what trig rule do I use. So if you have a triangle, the first question is, does it have a right angle? If it does, you're dealing with your right angled trig. Think Pythagoras' theorem, SOHCAHTOA, and half times base times height. We have our opposite side, our adjacent side, and our hypotenuse, and every triangle has a right angle. Or don't forget that our Pythagoras' theorem is c squared equals a squared plus b squared. If it does not have a right angle, you're dealing with non-right angled trig, which is not SOHCAHTOA, it's the sine rule and the cosine rule. You're also dealing with half AB sine C if you want to find the area of a triangle. If you have a matching pair, i.e. you have an angle and its opposite side, you can use the sine rule. If you're finding an angle, you use sine A over A equals sine B over B equals sine C over C. If you're finding a side, you do A over sine A equals B over sine B equals C over sine C. If you do not have a matching pair, you're dealing with the cosine rule. If you're finding an angle, you use cos C equals A squared plus B squared minus C squared over 2AB. And if you have no angle, if you're finding a side, you do C squared equals A squared plus B squared minus 2AB cos C. Okay, bearings. This is the one thing that I think is like universally hated. Like I've never met someone, a student or a tutor alike, who likes doing bearings. Bearings are the direction of one object from another. So there are two different types of bearings. The first one we have are what we call compass bearings. And compass bearings is like, I'm just going to show you this stuff. So this is a compass bearing. If I put my phone somewhere, I'm getting a compass bearing. It might be something like 322 northwest. There is another type of bearing, i.e. true bearings, which is what we're going to be talking about and how they can be used in questions that also talk about the sine and or cosine rules. So true bearings measure the size of the angle clockwise from north. They are always 3 digits. So this true bearing is going to be this angle from north. So 90 minus 31 is going to equal 90 minus 31 is going to equal 59 degrees. So if you were doing the compass bearing, it would be north 59 west, but as you're doing the true bearing, you're doing 90, 180, 270 plus 31, which is 301. And this one here is going to just be 56. And notice that we do the 0 in front because they're always going to be 3 digits. Alternate angles, and this is just to keep in mind when you're doing bearings questions, a couple things about angles. Alternate angles form a Z shape with the transversal. The transversal is this line here, passing through two parallel lines. So that's the line that intersects, we can say the parallel lines. Alternate angles are always the same size, so this angle is the same side as this angle. This angle is also the same size as this angle. Corresponding angles form an F shape. So here and here, this one and this one, or this one and this one, and they are also the same side. Don't forget, it's the line intersecting the transversal or the two parallel lines. Finally, co-interior angles are both on the same side of the transversal inside the parallel lines. So this angle here and this angle here. They are supplementary, which means that they add up to 180 degrees. So these two angles are going to add to 180. These two angles add to 180. These two add to 180. And these two add to 180. Okay, exam question 1. Aaron wishes to cut a 6-meter piece of timber into 3 pieces in the ratio 3 to 2 to 5. What will the length of the 2 shortest pieces of timber be? Okay, so we have 3 to 2 to 5. When we think about ratios, we want to think about them in parts. So 3 plus 2 plus 5, if we go 3 plus 2 plus 5, we have 10 total parts. We know that there is a 6-meter piece of timber. We're going to divide 6 meters by 10 parts, and we get 0.6 meters per part. Which means the shortest, which is 2 parts, is going to be 2 times 0.6 meters, meaning our shortest is 1.2 meters. And our next shortest, which is 3 meters, is going to be 3 times 0.6, which is 1.8. Okay, exam question 2. The table shows the average energy used in kilojoules per kilogram of body mass by a person walking for 30 minutes at different speeds. Our first person is walking for 3 kilometers, and they 3 kilometers an hour, and they burn 5.53 kilojoules per kilogram. And our second person is walking 5 kilometers an hour, and they will burn 7.37 kilojoules per kilogram. Sam, who weighs 65 kilograms, drinks a regular cappuccino made with full cream milk. It contains 73 kilocalories. For approximately how long must Sam walk at 3 kilometers an hour to burn off the energy contained in the cappuccino? Now, 1 kilocalorie is 4.184 kilojoules. So to work this out, we're first going to work out how many kilojoules were in the cappuccino. So because there were 73 kilocalories, we're going to times 73 by 4.184, which is how many kilojoules are in a kilocalorie, which means that there were 305.432 kilojoules in that cappuccino. If he's walking 3 kilometers an hour and he's burning 5.53 kilojoules per kilogram, we learn that if he's 65 kilograms and he's walking for 30 minutes, he's going to burn 359.45 kilojoules in the 30 minutes. We then want to work out how many burned per minute. So if we take 359.45 and we divide it by 30 minutes, it means that we're burning 11.9816667 kilojoules per minute. And if there were 305.432 kilojoules in the original cappuccino, we divide that by our new rate of burning, which is 11.98, etc., meaning that it will take 25.49161219 minutes, approximately 25 minutes to burn off our cappuccino. So our answer is B, 25 minutes. The blood alcohol content of a female can be estimated by the following formula. BAC for a female is 10 number of drinks, or standard drinks, minus 7.5 hour times the hours spent drinking, over 5.5 times the mass of the person in kilograms. Jackie, who weighs 72 kilograms, has a blood alcohol content of 0.04 after consuming 3 standard drinks. Approximately how long has she been drinking? So we're not trying to find the BAC, we're trying to find the H. So we know that she's got a BAC of 0.04. She's had 3 standard drinks and she's 72 kilograms. We're trying to find our H. So the first thing we're going to do is just times our brackets. 10 times 3 and 5.5 times 72, and we get this formula here. 0.04 equals 30 minus 7.5H over 396. So now we want to times both sides by the denominator, which means we just need to times the front, because when we times the back, it will just be evening itself out. So 0.04 times 396 is 15.84, and that's now equal to 30 minus 7.5H. We can now subtract 30 from each side, which will give us negative 14.16 equals negative 7.5H. And we can then divide each side by negative 7.5 to get H equals 1.888, which is approximately 2 hours. So if we were back in our question, we would be answering with B, 2 hours. In a school experiment, a student measured a length to be 9.4 centimeters. What is the upper limit of accuracy of this measurement? So we have 9.41, 9.45, 9.5, or 9.9. Our solution is as follows. Our upper limit of the measurement is going to the measurement plus the absolute error. And remember, absolute error is half times precision. So to find our precision, we're going to go into our measurement, 9.4, and we can see that the smallest number is the 0.4, which is really 0.1 centimeters, which is here. Our absolute error, therefore, is going to be 0.1 times half, which is 0.05 centimeters. Therefore, our upper limit is going to be our measurement plus our absolute error. So 9.4 centimeters plus 0.05 is 9.45 centimeters. All right, our next exam question. Corinne is in Athens, which is 2 hours ahead of Universal Coordinated Time, or Coordinated Universal Time. Marco is in New York, which is 5 hours behind the Universal Coordinated Time, or Coordinated Universal Time. Corinne is going to ring Marco at 10 p.m. on Tuesday, Athens time. What day and time will it be? Apologies, guys. What day and time will it be in New York when she rings? And secondly, Marco is going to fly from New York to Athens. His flight will leave on Wednesday at 9 a.m. New York time, and it will take 11 hours. What day and time will it be in Athens when he arrives? So our first section, we want to draw a timeline for our questions. New York is -5 and Athens is +2, which means that there is a 5-hour difference to Greenwich and then plus another 2 hours to Athens, 7-hour time difference. Because there is a 7-hour difference, when it is 10 p.m. on Tuesday in Athens and we minus 7 hours, it's going to be 3 p.m. on Tuesday in New York. So Wednesday, 9 a.m. New York, when the flight takes off, if we add 7 hours, is actually Wednesday at 4 p.m. in Athens. And then if we add the 11-hour flight time, Wednesday 4 p.m. plus 11 hours is Thursday at 3 a.m. in Athens. Our final exam question for measurement. Find the area of triangle PQR correct to the nearest square meter. So we can see that we have PQR, 166, 10, 100 meters and 80 meters. So our solution is as follows. Because area is half times AB sine C, we need at least one angle. And because we have all of our sides, we can use the cosine rule. So cos C is equal to A squared plus B squared minus C squared over 2AB, which means that cos R, we're looking for this angle here, is going to be 100 squared plus 80 squared minus 166 squared over 2 times 100 times 80. And take note of the fact that we're using the two sides, either side of the angle is A and B, and this is side C. That will give us 134 degrees, 12 minutes, and 24.43 seconds, which means that we can now do our area formula, half times 100 times 80 times sine 134, 12, 24.43. And that will give us an answer of 2867.312122, which is really equal to 2,867 meters squared. Make sure you write squared. Okay, what else can be covered in measurement? Because measurement is a massive subject. Conversions between measurements like length, mass, area, capacity, volume, and energy. We've also got errors in measurement, like we just spoke about, precision, absolute error, limits of accuracy, and percentage error. We didn't cover that. Significant figures and scientific notation, that's from year 11. Perimeter area, volume, and surface area, and that's from year 11, covering your common shapes like trapeziums, sectors, composite shapes, pyramids, and cylinders. We also have the trapezoidal rule and Pythagoras from year 11. Working with time, including timetables for things like public transport, is also from year 11. We have our right and non-right angle trigonometry, sine and cosine rule, area, bearings, angles of elevation and depression, and finally rates and ratios and scale drawings. That's all stuff that a lot of people forget can be covered, and it's super important that you review all of this stuff before the exam. We are now on to our final topic, financial maths. We're going to start with credit cards because this is a really tough bit that a lot of people get wrong. Credit cards are payment cards which allow users to purchase goods and services when you essentially promise the bank that you'll pay them back, as well as additional charges that they tack on. Some credit cards will have an interest-free period and others do not. This is why it's super important to read the question, because they may say something like, this credit card has a 15-day interest-free period, and then another one will say this credit card doesn't have any interest-free period, or there's no interest-free period, full stop. Okay, so that's credit cards. We use the same formula for credit cards that we use for compound interest. FV equals PV, so future value equals present value, 1 plus the rate to the power of n. So this is on your reference sheet. It is in the top right-hand corner here, but this is one that you just basically need to know because you will use it very often. Sometimes the question will actually specify using simple interest or a flat rate, so make sure you read the question carefully. That's the feedback with everything. Always read this stuff super carefully. Annuities. This is another thing that people struggle with, but I think is super easy. We have two different aspects of annuities. We have the future value of an annuity and the present value of an annuity. So very simply, an annuity is an investment account with regular equal contributions. So let's say that I have a trust account, or I have a lot of money for some reason, and I decide that every 6 months I'm going to put $1,000 into this account. Every 6 months I will put $1,000 in, and every 6 months I come back, interest has compounded, I add another $1,000. So annuities are like annual regular contributions, but they can be monthly, 6 monthly, or biannually, every 3 months, quarterly, 4 months, whatever it is. So to calculate the future value of an annuity, we use a table of future value interest factors. Now these tables are going to allow you to really, really easily answer annuity questions, and you're never going to be asked to figure it out without the table. Those calculations are quite difficult. They're not in the syllabus, thank God. So this is what those would look like. They're just for your understanding. Don't worry about memorizing them. Okay, exam question 1. This is from Money Matters in the Year 11 syllabus. Tom earns a weekly wage of $1,025. He also receives an additional allowance of $87.50 per day when handling toxic substances. What is Tom's income in a fortnight in which he handles toxic substances on 5 separate days? So to work this out, we have a fortnight, which is 2 weeks, 14 days. He makes a weekly wage of $1,025. So we're going to times that by 2 to find his wage from 2 weeks of work, $2,050. Then we want to find the $87.50 additional allowance over 5 days. So $87.50 times 5 is going to give us $437.50. And when we add those together, we get $2,487.50, which is our final answer, D. Sophie, I guess that's me, has a new work truck that she purchased for $38,990, and it's depreciating using the declining balance method at 12.5% per annum. Now, it's on our formula sheet. Our declining balance method is S equals VO 1 minus R to the power of N. Notice how it's basically the compound interest formula, but this is a minus instead of a plus. To the nearest dollar, how much value will the truck lose in the first 5 years? So our solution, we have that formula. We know that the original purchase price was $38,990, and we have a declining balance percentage of 12.5% per annum. And then we have a time period of 5 years. So we're going to put all of that into our formula, and you should get $19,998.3194, which really we can just say is 32 cents. So to the nearest dollar, how much value will it lose in the 5 years? Remember, this is actually the value of it after 5 years. So we need to subtract that new value from our original value. So 38,990 minus 19,998.3194 is equal to 18,991.6806. Meaning that the truck lost $18,992 to the nearest dollar. Okay. So this is our exam question 3. The table shows the tax payable for different taxable incomes. Now this changes all the time, so don't bother memorizing any element of the table other than how it works. Leslie has a gross annual salary of $92,000 and tax deductions of $1,200 for work-related travel and $350 for stationery. The Medicare levy to be paid is 2% of the taxable income. Leslie has already paid $22,400 in tax. Will Leslie receive a tax refund? Justify your answer with calculations. Okay, so the first thing we're going to do is work out the taxable income. We know that Leslie had a total income of $92,000, but there were deductions of $1,200 and $350. So really the taxable income is $90,450. If we go into our table, we can see that $90,450 falls into this tax bracket, which means that she's going to pay $19,822 plus 37 cents for every dollar over $87,000. So we want to find the amount of money over $87,000. So we subtract $87,000. So 90450 minus 87,000 is 3,450. So our tax payable is going to be 19,822 plus 37 cents for all of these dollars. So 0.37 times 3,450, and our total tax payable is going to be $21,098.50. And we have to add to that our 2% Medicare levy. To find that, we do 2 over 100 or 2% times 90450, which is our Medicare levy. So our total tax payable is $22,907.50. Apologies, guys. As you can probably imagine, talking for 2 hours straight definitely takes its toll on your voice and your lips. So give me 1 second. Okay, so Since Leslie has only paid $22,400, this is less than the required amount, which was $22,907.50. So Leslie does not get a tax refund, unfortunately. Leslie actually owes money to the tax office, and we can work that out by finding the difference between $22,907.50 and $22,400. Okay, this is our second last question. Part of a supermarket receipt is shown. Determine the missing values A and B to complete the receipt. So we can see we have chocolates is A, tomatoes or 1 kilo was $5, almonds is B, cheese slices $8.50, milk $3.20, bananas $2.85. We have our total amount at $36.25. So if we want to find the solution, we know that the chocolate we can see includes the GST, as we had the asterisk, and the natural almonds does not include GST, which means that chocolates is going to be 110% of the price versus natural almonds will be 100%. So with the GST included, we can see 0.70. Chocolates is 70 cents, which was the 10%. We can see again, this is why we know this. Because 70 cents is 10% of the price, we can determine that $7 is 100% of the price. So $7.70 for the chocolates. The almonds, however, do not have the GST included in the price of the item. So we just need to work it out via deduction. So $36.25 minus the $5 for the tomatoes, the $7.70 almonds, the $8.50 cheese slices, the $3.20 milk, and the $2.85 bananas, we get $9 left over, meaning that for our receipt to add up correctly, our natural almonds must have been $9. Okay, this is our final question, and then I'll be doing a bit of a chat through a couple things at the end. A teacher bought 2,500 shares in a business 2 years ago at $5.25 a share. The share price of the business has increased by 36%. Calculate the increase in the value of the investment. So our initial value we can see was $5.25 a share. There were 2,500 shares bought, which means that the initial value of that share portfolio was $5.25 times 2,500, $13,125. That share price, or value rather, has increased by 36%, meaning that the increase in the value of the investment is going to be 36% times 13,125, and that's going to equal $4,725. That is the end of our questions. So please drop any question you have in the chat. We have about 20 minutes left of the lecture, 15-20 minutes. So I am going to run through all of the questions that I always get at the end of the lecture out loud, because I don't like typing these answers out because they're quite lengthy. I like to actually deliver them to you guys. So the first thing that I like to talk about is approaching our actual exams. This is a quick guide that I recommend. You are about here right now in terms of how far out from the exam you are. So finalizing notes, hopefully that is done and dusted. If you have not finalized your notes yet, don't finalize your notes. There's no point. You need to focus on just working on your papers with the reference sheet and with timed conditions. So this box here is where you need to be. If you're already there, perfect. Continue on this path. You're doing great. If you're not, you need to focus on getting to that green box, because this is where you're going to get the most return. If you do 3 papers here, you're getting far more return than doing 5 papers here. If you are already in the green box, but you feel like you're not progressing, you're doing 10 papers a week and your mark is staying at 60%. Now it's time to figure out what it is that you are not getting correct. So are you getting your simultaneous linear equations all incorrect, or are you just messing up all the networks questions? When you are doing a practice paper and you realize that you continue to get the one section of questions wrong, that's when you step back from the practice paper and you move back into chapter reviews or reviews for just that section of content. Hopefully that kind of helps. with what I've got on the screen. I'm now going to talk about 3 different things that I usually get asked: past papers, motivation, or burnout. I'm just making this list so you guys can follow along. I like to be signposting this kind of stuff. And thirdly, just HSC exams, and like we talked about earlier, what to do on the actual day. So the first question I get heaps is, where do I find past papers? Or I've gone through my past papers, or how do I, continue finding new questions? The first thing I would point to is, obviously slightly biased, but if you're familiar with ATAR Notes Ed Unlimited, Ed Unlimited has now changed names to ATAR Notes Plus. So ATAR Notes Plus, we have some maths past papers on there that you can use. Those are a paid model, but I think that they're very well written and I would really recommend them. I think the solutions are particularly really good, especially in the topic test booklet. The solutions are super, super lengthy to give you a good idea of how to actually receive the correct marks in a question. If you are already using ATAR Notes Plus materials, or you don't want to, ACE HSC is online and it has free resources. There aren't a million, but there's definitely a number of maths past papers on there. Obviously, the HSC past papers, try and save the 2019, 2020, 2021, 2022 papers for as close to the exam as possible, because those are the most realistic to what the exam's actually going to be like, because they're the new syllabus, they're the newer papers, they're the right length, they're the newest content, everything. So try and save those ones. Do the 2012, but before you do the paper, go through and knock out the questions that you don't actually have to do because they're not in the syllabus anymore. You can also use chapter reviews from your textbook or content that you've covered in class, like slideshows or worksheets, as your practice papers. So there's probably not a great chance that you remember questions you did 6 months ago. You can always reattempt the same worksheet, reattempt the same PowerPoint, go back to your textbook, find a chapter review and reattempt that as well. The second thing I always get asked about is motivation, procrastination, and burnout. The point where you guys are at now, I can't give you the same advice I would give my year 11s about motivation or procrastination. I personally found it pretty hard towards the end of the HSC because I graduated, I was at home studying, and I just kind of stopped, to be honest with you. I know that the day before my English exam, I remember it so vividly, I just sat in my room all day. I didn't do anything, I didn't write anything down, I read my quotes and that was about it. And I still got a band 6. I got a 90 something in that exam because I had faith in the fact that I had done a crap ton of work all year. And as most of you probably can attest to, you've done work all year. It's not what you do in the final 2 days that changes the outcome of the exam. You need to rely on the fact that you have been working towards this all year and you have a bunch of stuff up here that is going to assist you in the exam. Sure, you need to remember your quotes or you need to remember your formulas or whatever it is, but you've been looking at this for hopefully about 2 years straight now. So if you feel like with 19 days to go to maths and probably something like 2 weeks to go to English, you're not even able to focus anymore, that's not unusual. And it's probably a sign that you need to start taking some serious time off. I know that seems so counterintuitive, but this is not the end all be all. And it's better that you look after yourself mentally and physically over just burning out completely and not even being able to sit the exam because you're so exhausted. When it comes to staying motivated, the first point I would raise is it is over so soon. You really are so close to the end, and some of these final days are going to be really hard and kind of pushing through and working hard. But trust me, it is all worth it. It will be over. You'll have some of the best months of your life out of school, not in uni yet, maybe just working a part-time job, enjoying the weather. It's going to be great. It was some of the best time of my life. I loved it, but it's something to look forward to and it's something to motivate you to continue to work hard in these last few weeks. When it comes to procrastination, a few tips that I like to give. Number 1, try and break your work down into super manageable chunks. I know that's easier said than done. I have, all weekend been working off one big to-do list that has things as easy as fill out my planner or finish a uni module or clean this drawer or something like that. So it's super easy for me to be able to tick multiple things off a day and it doesn't feel super overwhelming to look at and oh my goodness, I can't tackle anything on this to-do list. There's just too much that I'm staring at right now. The other thing that with procrastination that I would really recommend if you're in these final couple weeks and it's really bugging you is try and figure out what type of procrastination you have. Do you have a stress procrastination where you're so stressed that you can't even start the work? If that's the kind of procrastination you identify with, I would recommend the 5-minute technique where you only have to do the work for 5 minutes. Because what will happen is you'll start the 5 minutes, you'll realize it isn't actually as bad as you thought it was, and you probably can get through it. And you could probably do half an hour or an hour or even more. So I would recommend giving that technique a go if it's stress procrastination. With stress procrastination, it's also super helpful to break that work down into super manageable chunks, as I said. The next thing is if it's just distraction procrastination. That is my problem. This just distracts the living hell out of me. It is so bad. I will always be grabbing it and looking at it while I'm studying. So my recommendation is to use this app called Forest. It is like $2.99 on the App Store, I think. And you get to plant cute little things like mushrooms or all of these trees that I've unlocked. And you then build a forest with the trees you plant. If you go on your phone while you have a tree growing and you access a different app, you will kill the tree. This is my forest from 2023 so far. I have focused for 41 hours and 5 minutes, and I know that my most focused time is Saturdays, and my most focused day is Saturday, and my most focused time is 4 p.m. And I can tag things. What am I working on? What am I focusing on? I really, really like having this app. It's really helpful. For some reason, I really get upset about killing the imaginary trees. So I would really recommend that. Another thing that I like to do is because I get so distracted by so many different things, I like to have a notebook or a sticky note next to me while I study, and all the things I think about, like put the dishwasher on, do my laundry, Google that one movie from 2003 that I want to watch, check Instagram, staple that piece of paper, whatever it is. I write everything down as I'm going because those are all the things I would usually use as an excuse of like, oh, I have to go do that. I probably don't have to go do it. I have to do what I'm doing right now. But I write them down in a list so that when I finish studying, all those things that I wanted to do while studying, I can come back and readdress. And I think that's really helpful because it's kind of nipping yourself and not letting yourself get distracted by all of these different things that you can go and do, and just focusing on the task at the moment. When it comes to listening to music, I really like listening to lo-fi. If I'm trying to work really fast, sometimes I'll put on like more of like an EDM vibe, but anything with lyrics tends to distract me unless I'm doing something that's like very mindless, like typing out quotes or something like that. That would be all of my recommendations for motivation, burnout, procrastination, etc. When it comes to the third point, actually sitting your HSC exams. Number one, make sure that you are getting a really good night's sleep the night before your exams. I actually cannot understate this enough or overstate this enough. The quality sleep you get before your exam will fundamentally change the outcome. I'm talking 70 versus 90 on the exam. If you get a bad night's sleep, if you toss and turn until 4 a.m. and you wake up 3 hours later, you are not going to do well in that exam. Sleep is the actual cure to so many things. And if you're in bed at 9 p.m. the night before that exam, like in your little cocoon with your bottle of water and your sleep tea or whatever it is that you like, and you've done your nighttime routine, you've had a bath or a shower, and you've lit a candle and you've taken a deep breath, that is going to do you such wonders compared to stress studying the night before. We all stress study, but I promise you, it's not going to get you anywhere. You can revise quotes or you can read formulas, but you're not going to learn how to do the network concepts material the night before the exam, unless you're superhuman. In that case, well done. The quality sleep you get is super important. I would recommend not drinking coffee the morning of an exam. I just skipped it because honestly with coffee you can never know, like it might mess with you that day. You might get too jittery because you're all kind of naturally anxious anyway. I just drank a little bit of water and I had a small breakfast, or sometimes I wouldn't eat breakfast. That was just me personally. You probably really should eat breakfast. I think it's way better to go in with a full stomach. Especially if you're dealing with 2 exams in a day. I know that I had that situation, and yeah, you need to eat. And when it comes to actually sitting the exam, when you get to school, make sure that you have your transport planned out the night before, whether you're getting driven or someone's driving you or you're taking the bus. Take the earlier bus, take the earlier train, leave home 20 minutes early. Don't let any of those stupid little things get in your way, like not having your uniform ironed or not having the bus come on time, whatever it is. Don't let any of those little things mess with you. Move ahead of them by being early and being prepared. When you get to school, I had an experience where I got to school and everyone was kind of over it, to be honest. So the vibe was actually really great. We were all just kind of laughing about how it was finally here. We couldn't believe we were sitting the HSC and it was done. But if people around you are stressing you out, stay away. I would sit by myself, put my headphones in, just think and be present. And the last thing is, with all of your kind of materials, buy a new calculator, have a backup calculator, take 60 pens, whatever it is that makes you feel prepared. Have the clear bag, have the water bottle, make sure that your phone goes in your locker and it doesn't stay in your pocket. All of those little things are super important. Label your reference sheet. Remember, you can't write during working time or reading time. You can only write once that 2 hours and 30 minutes starts. So make sure that this sheet remains blank for the first 10 minutes and then you can fill it in. But above all else, this is not going to determine the outcome of your life. It is merely a stepping stone that can get you to great places or can throw an extra 3 months into your plan. It's not going to determine anything majorly important to your life. Most people my age don't remember their ATARs. My friends and I were having a laugh about how we couldn't even remember them a couple weeks ago. I just remember it when I have to put it in these presentations. These things are so inconsequential. They are a blip. Right now, they are everything to you, and I fully appreciate that because it was everything to me too. But I have faith that you're going to do well, you're going to work hard, and you will get the result that hopefully that you deserve. Those are kind of all my comments. We're going to wrap up now a couple minutes early. I hope this has been super, super helpful to you guys. This is probably your last lecture series with ATAR Notes if you've been with us before. I'm sure that, there's many of you I've never interacted with in my classes or in my privates, but I want to thank you for coming to these lectures and supporting us. We love being here to support you guys. We were in your shoes only a few years ago. We remember how stressful it was, and I'm so glad that you're hopefully getting something out of these lectures. If you have anything else that you would like to ask me, please leave it in the chat below. I will hang around for about 5 minutes after the lecture if the questions keep coming through. So please keep popping them in the chat and I will be sure to answer them. Thank you so much for being here with me today, guys. I hope you found this helpful and a good kickstart for your revision today. Any further questions, leave them in the chat. Best of luck, you guys. I feel it. You're going to smash it. I know. Good luck with everything after the HSC. Good luck with uni. And don't forget, once you move into uni next year, check out Uni Notes, ATAR Notes, but for uni. Thank you so much, guys. Good luck, Year 12. You're going to smash it. I feel it in my bones. I know it. I feel it in my waters. I'll manifest it for you. Don't you worry. Good luck, you guys. Have a great holidays afterwards. And thank you for being here. Bye.